Hi, my dear students. In last couple of days, we were discussing about the nature of simultaneous equation model and how to handle or how to estimate the simultaneous equation model. Okay. So in the beginning itself, I have told you that a simultaneous equation model is an equation where there will be more than one equations. Okay. And the variable in these equations are jointly determined. And if we want to estimate one of the equation in this system or in this models, we have to take into account the information provided by the other equations. Okay. Yes. So when we have a simultaneous equation and we have a limitations to apply Euler's, because if we apply Euler's, it will lead to simultaneous equation bias. Okay. And it will also leads to the violation of some of the assumptions, and it will not satisfy the unbiasedness properties as well as consistency. Okay, so in the presence of a simultaneity in an equation or in a model, uh, still if we apply the Euler's, okay, the result will be biased as well as inconsistent. Okay, yes. So in order to move further, uh, we have discussed two types of equations, structural equations and reduced form equations. Structural equations are basically describe the structure of an economic theories, okay, or what your theory actually says, okay, that we are returning in pure mathematical form or in algebraic form, okay. So in structural equation, there will be one equation for each jointly determined variable or endogenous variables. Okay, in the right hand side variable, there will be predetermined variable as well as endogenous variable. Okay, so in order to uh, make further, in order to make all the exogenous variable in the right hand side, okay, we have to reduce these equations. Okay, this is what is called reduced form equations. In reduced form equation, there will be one endogenous variable. Okay, all the endogenous variable will come into the left hand side, all the exogenous variable will come in the right hand side. Okay, so after that, we discussed what is identifications. Okay, identification is just we are checking the possibility or impossibility of reaching or estimating the parameter of a structural equation from the reduced form equations. Okay, so from a reduced form equations, can we revert back into the structural equations? If it is possible, then the equation is identified. Okay, then we discussed identification can be over identified or exactly identified. Okay, so an equation is under or it can be under identified also. Okay, so if an equation is under identified, if the structural parameters cannot be expressed in terms of the reduced form equations or reduced form parameters. Okay, from reduced form equations, if we cannot back to the real structural equations, then the equation is under identified. Okay, so for example, there are four structural parameters, okay, and there's only two reduced form equations. From two equations we cannot estimate or we cannot solve or we cannot find four parameters. Okay, uh, then the equation is exactly undefined when the structural parameters can be uniquely expressed in terms of the reduced form parameters. Okay, then sometimes an equation can be over identified. This is the case when we have a more than one solution for expressing the structural parameters in terms of reduced form parameter. Okay, we have five equations and we have only three structural equation to be estimated. Then we have multiple solutions. Okay, so this is the case of over identified equation. Okay, Yes. So next, the problem is it is very difficult to do the identifications, in the sense that first we have to construct a structural equations, then reduce form equation, then we have to check whether we can find out the parameters of a reduced form from whether we can find out the parameters of a structural equation from this reduced form coefficients. Okay, so it is very difficult to do. Okay, so some econometricians, they have developed some conditions. Okay, the identification condition or condition for identifications. Okay, so there are basically two conditions. One condition is order condition and another one is the rank condition. Order condition and rank condition. Okay, so in this video we are going to discuss what is order condition. Okay, so the order condition says that the number of variables, both endogenous and predetermined, excluded from an equation but included in other equations. In a simultaneous equation, there are more than one equations. Okay, then you take one equation, and in this equation, the number of variable excluded from this equations, but these excluded variables are included in the next equations. Okay, so it must be greater than or equal to the total number of equations less 1. The number of variables excluded from an equation but it is included in other equation must be greater than or equal to the total number of equations or total number of endogenous variable, because for each endogenous variable there will be one equation. Okay, so total number of equation in a simultaneous equation will be equal to the total number of endogenous variables. Okay, less 1. This is the definition that we can give to uh, the order condition. Okay, so you take an equation. This is the hypothetical example of hypothetical example of simultaneous equation model. Using this example, I will discuss or I will tell you what is the excluded from an equation, what is the included from other included in other equation and all. Okay. So look at this equation y1t minus beta 10 minus beta 12 y2t minus beta 13 y3t gamma 11 x1t is equal to u1. Okay, so in this equation, in this system of equation, this is a system of equations. This is equation 1, equation 2, equation 3 and equation 4. y1, y2, y3, y4, these are all endogenous variable. x1, x2, x3, all these are all exogenous variable. Okay, yes. Now you look at basic in this equation, y1 is there, y2 is there, y3, y4. Okay, then x1, x2, x3, x4. Okay, but in somewhere some variables are missing. Okay, if you look at this, you will realize that where are these missing variables. Okay, now you look at y1t. Actually, all those variables are, this is the parameters y1, y2, y3, y4, x1, x2, x3. Okay, so if you look at the system as a whole, you can find 1, 2, 3, 4, 5, 6, 7, 7 variable and one intercept. Okay, so you look at this table. Okay, you look at the first equation, this equation 1. The intercept is beta 10. This is the intercept. Okay, now y1, this is the, yeah, y1 is there. What is the parameters of y1? Y1 parameter is 1. Okay, yes. Now look at y2 is there. In this equation y1 is there, y2 is there. Okay, the parameters of y2 is equal to minus beta 12. minus beta 1 2. Okay, then y3 is also there. Parameter is minus beta 1 3. Okay, then y4 is not here. Okay, so y4 is excluded from this equation, but it is included in some other equation. You got the point? Yes. So y4 parameter will be 0. Okay, then x1 gamma 1 1, x2 is excluded from this equation, x3 is also excluded from this equation. Okay, yes. Now look at second equation. The parameter, sorry, the intercept is beta 20. This is beta 20. Okay, so in this equation, y2 is there, but no y1. Okay, so y1 is excluded, so 0. y2 is 1. Okay, y3 is minus beta 2 3. Okay, y4 is not there, so y4 is excluded. Then x1 is gamma 2 1, and x2 is minus gamma 2 2, x3 is excluded. Okay, so this is the parameter of the second equation. Then third equation, beta 30 minus beta 3 1, then y2 is excluded, y3 is 1, parameter is 1, y4 is excluded, x1 is minus gamma 3 1, and x2 is minus gamma 3 2. Last equation y4. Okay, intercept is beta 40, y1 is minus beta 42. Okay, y2 is minus beta 42, y3 is 0, y4 is 1, x1 is 0, x2 is 0, only x3 is there. Okay, its parameter is minus gamma 43. Okay, so this is the equations of a structural models. Okay, so from structural model, uh, we identified that what are the variables are excluding from this model, and what are where these excluded variables are included uh, in some other equations. Okay, so and on the basis of these exclusions, okay, so excluded variable, the parameter will be equal to 0. Okay, so on the basis of such information, we are creating a table of coefficients. Okay, yes. Now yes, the condition was in a simultaneous equation model. Okay, and so there will be m simultaneous equations. The number of predetermined variable excluded from an equation must not be less than the number of endogenous variable included in the equation less 1. Okay, the same thing. Okay. So what I am going to do is these definitions. Okay, I can convert into an equation. What is that? K minus k, capital K minus small k, greater than or equal to m minus 1. Okay, this is nothing but we are just converting the earlier two definitions. Both definitions are same. Okay, but the wordings are different. Okay, so what is this k and all? This k is the number of predetermined variable in the model. Okay, then small k is number of predetermined variable in a given equations. Okay, so if it is capital K, how many number of predetermined variables are there in the system? Then if you take small k, then it is number of predetermined variable in a given equation. Okay, then what is m? This is small m, so it is number of endogenous variable in a given equation. Suppose we are going to check first equation. Okay, k is what? Number of predetermined variable in the equation as a whole. Okay, then small k is number of predetermined variable in a given equation. Okay, or in an equation that you are going to check. Then m is the number of predetermined variable. Okay, so if k minus k is exactly equal to m minus 1. Okay, so it will be an exactly identified equation. Okay, then if it is greater than m minus 1, k minus k is greater than m minus 1, it is over identified. Okay, so this greater than or equal to denotes the equation is exactly identified or over identified. Okay, so if the both case in the both case also in the both cases the equation is identified. Okay, but if m minus 1 is greater than k minus k, then the equation will not be identified, or it is called under identified or unidentified. Okay, now you look at our table. Okay, so in the same table is repeating here. Okay, so look at this equations. We are going to check the first equation. The first equation is identified or not. Okay, then look at number of predetermined variable excluded. That is, this is what is called k minus k. Okay, so number of predetermined variables. So predetermined variable are basically exogenous plus lagged endogenous plus lagged exogenous. Okay, so how many predetermined variable excluded? Look at this equation. Where is the 0? Yeah, x2, this is 0, this is also 0. There are two exogenous variable that are excluded from this equation. This is also excluded, but this is not exogenous, this is endogenous. Y4 is endogenous. Okay, so 2, yes. Okay, then number of endogenous variable minus 1. Okay, so 1, 2, 3. Okay, so three endogenous variables are there. Minus 1 is equal to 2. Okay, so k minus k is equal to 2, m minus 1 is equal to 2, 2 is equal to 2. So what we can say, the equation is exactly identified. Okay, now you look at the second equations. Okay, how many k minus k are there? Only one. X3 is only excluding. Okay, then how many endogenous variable included less one? One, no, this is not it. One, two. Two endogenous variables are included, less one. 2 minus 1 is equal to 1. Okay, so k minus k is equal to 1, m minus 1 is equal to 1. So it is also exactly identified. Okay, look at third equation. K minus k. Okay, only one, x3 only. Okay, so m minus 1, this is endogenous variable 1, 2. 2 minus 1 is equal to 1, so 1 is equal to 1. Okay, so the third equation is also identified. Look at the last one. Okay, 1, 2. 2 x1 and x2 are excluded. Okay, and these x2 and x1 and x2 are included in some other equation. Okay, look at 3. 3 is included, 2 is also included, but 4 is not. 4 is excluded. Okay, and look at endogenous variables. Okay, y1, y2, y4, 3. Okay, 3 minus 1, 2. Okay, so k minus k is equal to 2, m minus 1 is also is equal to 2. Okay, so here also we can say that this equation is also identified. Okay, in all these four cases the equations are exactly identified. Okay, so this is the case of, or this is how we can do, how we can analyze whether an equation is identified or not using order conditions. What the equation, k minus k is equal to greater than m minus 1. If it is the case, then equation is identified. If it is not the case, then equation is not identified or under identified. Okay, now look at some other equations. Okay, the first equation is q dt is equal to alpha 0. We can check some of the variable whether they are identified or not. Okay, or some of the equation whether they are identified or not. Okay, look at this equation q dt. quantity demand for commodity is equal to alpha 0 plus alpha 1 price plus u1. Okay, then quantity supplied is equal to beta 0 plus beta 1 p plus u2. Okay, so look at how many endogenous variables are there. There are only two endogenous variables, price and quantity. Okay, because QDT is equal to QS. Okay, so we are treating QDT and QST as Q. Okay, so Q and P, these two are endogenous variables, and this is two are endogenous, and this P is also endogenous. So Q and P are endogenous, and you look at the right hand side variable. If there is there any predetermined variable or exogenous variable? No, there is no exogenous variable. Okay, so to be identified, what is the condition? Each of these equation must be exclude at least m minus 1 variable. Okay, so this is not the case. Okay, so here we cannot exclude m minus 1 variable. Okay, and here there is no predetermined variables. Okay, so in this model, neither the equation is identified. You look at the condition k minus k. Okay, you take the first equation. How many m's are there? Only one m's. Okay, in first equation, the number of predetermined variable is, sorry, number of industrial 2, not 1, it is 2. Okay, yes, it's not, the m is not equal to, m is equal to 2. Okay, not 1. Okay, so k is not there, small k is also not there. Okay, so 0 minus 0 always greater than 2 minus 1. Okay, so equation is under identified. Okay, look at next one. QDT is equal to alpha 0 plus alpha 1 price plus alpha 2 income plus u1t or u. Okay, then QS is equal to beta 0 plus beta 1 p plus u2. Okay, now you just take the condition k minus k is equal to greater than or equal to m minus 1. Okay, first equation, how many m's are there? 2m, endogenous variable. QP, 2 endogenous variable. Predetermined variable in the system as a whole. Okay, so only one, y only is there. In the equations also only one predetermined variable is there. Okay, so small k and capital K is equal to 1. Condition, k minus k, 1 minus 1 greater than or is equal to 2 minus 1. Okay, so 1 minus 1 is equal to 0. 0 is greater than 1. The equation is under identified. You take the second equation. Here also m is equal to 2. Capital K is equal to 1. Small k is equal to 0. Okay, so 1 minus 0 greater than or is equal to 2 minus 1. Okay, so 1 minus 0, 1. 2 minus 1, 1. Okay, so in this case, the first equation is under identified, but the second equation is exactly identified. Is it okay? Yes. So this is for you. Here also there are two equations. Okay, QDT is equal to alpha 0 plus alpha 1 p alpha 2 yt plus u1t. QS is equal to beta 0 beta 1 pt plus beta 2 pt minus 1 plus u2. Okay, the second equation is QDT is equal to alpha 0 plus alpha 1 p plus alpha 2 yt plus alpha 2 rt plus u1. QST is equal to beta 0 plus beta 1 pt plus beta 2 pt minus 1 plus u2. Okay, so you check whether these two equations or two simultaneous equations are whether they are identified or not. Okay, so what you have to do, you take how many k are there, or how many small k are there, how many m's are there, you apply the equations and you analyze whether these equations are identified. Okay, so this is the work for you. Okay, after watching this video, you do this work and send to me. Okay, yes. So thank you. Tomorrow in the next session we will discuss the rank conditions for identification. Okay, thank you.